Flowcharts are a visual tool used in computer science to represent algorithms in a clear and structured manner. They depict the flow of processes through a series of steps, using symbols and connecting arrows to illustrate the logic and sequence of an algorithm. By presenting algorithms graphically, flowcharts make it easier to understand complex procedures, identify potential errors, and communicate the design of a solution to others. Their intuitive nature ensures that even those without a background in programming can follow the flow of an algorithm. A defining feature of flowcharts is the use of different shapes or boxes to represent specific types of commands or actions. Each shape has a standard meaning, enabling consistency and clarity. For example, ovals are commonly used to represent the start and end of a process, indicating where the algorithm begins and terminates. Rectangles, often referred to as process boxes, denote specific actions or steps to be carried out, such as calculations, data assignments, or function calls. Diamonds are used to represent decision points, where a condition is evaluated, and the flow branches based on the outcome, such as a yes or no answer. Parallelograms typically signify input or output operations, such as accepting user data or displaying results. These symbols, connected by arrows that indicate the direction of flow, create a visual pathway through the algorithm. Algorithms can be effectively written and represented as flowcharts, offering several advantages. A flowchart provides a bird's-eye view of the entire algorithm, showing not only the sequence of steps, but also the logical relationships between different parts of the process. For instance, consider an algorithm designed to determine whether a number is even or odd. In flowchart form, the process might begin with an oval labeled start, followed by a parallelogram to denote input of the number. A diamond would then evaluate the condition, is the number divisible by 2, with branches leading to different paths based on whether the answer is true or false. Each path could lead to a rectangle describing the output action, such as print even or print odd, before concluding with an oval labeled end. This visual representation makes the logic of the algorithm immediately apparent, ensuring that no steps are omitted and that all possible outcomes are accounted for. One of the significant strengths of flowcharts is their ability to simplify the communication of complex algorithms. For instance, when collaborating on a software project, team members from different disciplines might struggle to interpret code or technical documentation. However, a well-designed flowchart can bridge this gap by presenting the algorithm in a universally understandable format. Similarly, in educational settings, flowcharts are invaluable for teaching algorithmic concepts to beginners, as they strip away the complexities of programming syntax and focus on the underlying logic. Despite their many benefits, it is important to ensure that flowcharts are designed carefully to avoid confusion or ambiguity. Overcomplicating a flowchart with excessive detail or clutter can undermine its purpose, making the algorithm harder to follow rather than easier. Conversely, a flowchart that is too simplistic might omit critical steps or fail to convey the full scope of the algorithm. For instance, when designing a flowchart for a login system, it is essential to include all relevant steps, such as verifying user credentials, handling incorrect inputs, and directing users to different paths based on their authentication status. Omitting any of these steps could result in an incomplete or misleading representation. In conclusion, flowcharts are a powerful tool for writing algorithms, offering a visual approach that enhances comprehension, communication, and problem-solving. By using different shapes to represent commands and ensuring a logical flow between steps, they provide a clear and organized framework for understanding the structure of an algorithm. Whether used for simple processes or complex systems, flowcharts serve as an indispensable resource in computer science and beyond.